Welcome and hello. Today we're going to be tackling LeetCode 16, three-sum closest. This is a continuation of the three-sum problem from LeetCode 15. So I highly recommend that you go and do LeetCode 15 first and then come and do this problem. But with that being said, let's go ahead and jump right into the statement of the problem. So giving an integer of array nums, length of n, and an integer target, find three integers at distinct indices in nums such that the sum is closer to the target. And we need to return the sum of these three integers. So we need to get the sum and make sure it's as equal to the closest, or the difference in the sum, or not the difference, but the distance of sum is the minimum, the most minimum of the array. Now, with that being said, so as the problem statement again, we will reiterate, is the objective to find the summation of three integers in the array. So maybe like something like this. We need to find the sum, and we need to get the closest sum to the target. So we can take a quick look at the example here that was provided. So we take the first three over here. That will come down to the summation of being 2. And then we're gonna slide down the array and come down to here. And we'll have, there we go, sorry about that. 2 minus 4 plus 1. So it's going to come down to 3, but 3 is greater than 2, so we're going to say our closest is 2, which is what this output is. Now if we run into a case where we had got input array and the sum is equal to the target, we would return that right away. But how do we do all this? So this sounds all fun and amazing, but how do we actually do this? And let's go to the next slide and we'll talk more about it. So the approach to this is, first, you need to sort the array. So step number 1 is sorting, which using the Python built-in .sort functionality. Of the array, and once we sort the array, it will look like this. So we got -4, -1, and I think 1 and 2. And then the core logic here and the best technique that we're going to be using is a 2-pointer approach with a for loop. That being said, it might a little bit not make the most sense right now, but once I go through an example with you guys, it'll make a lot more sense, I promise. But going a 2-pointer with for loop, and we're gonna have a initial value of the closest, which is our answer, and that we will initialize to positive infinity. That being said, we're going to check if current sum is ever equal to the target. If so, return right away. If current sum is greater than the target, that means we have a much larger value that we had. Since we have sorted arrays, we can assume that the larger value comes from the right side, and we would decrement our right pointer, else we would increment our left pointer because we are too little compared to the target. So with that being said, let's go ahead and take an example. So like I said, initially we need to have a for loop. So index of I, and then we have a left pointer that starts at L equals to I plus 1, and we have a right pointer at length nums minus 1, so it'll be right here. And as long as we are iterating for the for loop, we have calculating the current sum, which in this case will be -4 plus -1 plus 2, which equals 2. This is -3. And then we check, hey, if, and we're going to take the absolute value, because we care about distance. We don't technically care about positive or negative at this point. We care about the actual distance between the target and the value of the sum of the value of the three inputs. And we're going to say, hey, what is the distance between the target and current sum if the distance between the current sum and the target is less than the closest absolute value again, closest, which is our answer, minus the target. And the closest is, as I'm going to use a different color here, right here. It's initialized at positive infinity. Then, let me go back to here. Then we would say our closest, we're going to update it to be the current sum. So let's go ahead and do a short stop and say, okay, at this point we are comparing -3 is less than positive infinity. So we're gonna say, hey, the closest is right now is -3. Now, where's my color difference? There we go. If closest is greater than the target, remember the target was, I think it was 2, right? No, sorry, 1. In this example, it was 1. So if the target is greater than if the closest value that we just made is sorry, we should be looking at the current sum. I made a small bug here. If the current sum, let me get rid of this. Sorry about that. If the current sum is greater than the target, that means we have a much greater value on the right side, and we're going to tell the right pointer to decrement. Else if current sum is less than the target, then we're going to increment our left pointer, which in this case we would, because we have a -3, and -3 is smaller than 1. So right here, our left pointer will be right here. And at this point, we're going to reiterate through this logic. I'm going to erase some stuff here, but I think you're already catching on to what I'm getting into. Is checking, let me get rid of the current sum. So we calculate the current sum again, and it's going to be -4 plus 1 plus 2, so that's 3, that's going to be -1, and we're going to check, hey, what is the absolute distance between -1 and 1, and that's equal to 2, and 2 is less than 3, -3 is -3 minus 1, and it's going to be 4. So right here the closest is now the closest now is negative 2. No, sorry, it'll be negative 1. The total difference between the distances is 2. But the closest is negative 1. And again, if current sum is greater than the target, it's not, it's actually less. So we're going to, again, update our pointer. We're going to come down to the left. And at this point, we have done with our while loop of the pointer, which will force us to, let me change, come down here. And now we go back to our for loop, and it's going to be right here. Our left pointer is here and the right pointer is there. So at this point, our current sum would equal, oh, sorry, let me go ahead and delete some of this stuff. So it'll be negative 1 plus 1 plus 2. So at this point, it will be 2. 2 minus 1, because the target, sorry, I flip these. 1. There we go. So we have 2, 1 minus 2. And distance here, because we have, again, an absolute value, is going to be 1. 1 is the distance between the closest target was the last time, I think it was 2. So now it's gone down to 1. And because the closest minus the target was 2, so 1 is less than 2, so we're going to say, hey, your closest sum is technically sorry, no. The closest is equal to the current sum, which is 2. Sorry about that, I was mixing up my head. So it would be, the closest is technically going to be 2, because again, this current sum is 2, and we're going to say, hey, is the current sum greater than target? And it is in this case. We're going to decrement our left pointer, and it's going to go down. But at this point, our for loop will keep on spinning, but nothing is going to come out, because our left and right pointers are always going to meet that base condition of while left minus r. So this is always going to be there. That being said, if we ran into a situation where, I'm going to change colors so stay consistent. So else, we would return current sum, because that would that at this point it's equal to the target. Target is found. But since we have not found it, we're just gonna, man, I said I'm gonna change this. Jeez, I'm so sorry. But you're getting the point here. If you've been following, you should be getting the point. So else, we would return current sum. Else, oh sorry, no, not else. Return closest. And this is basically our logic. I'm gonna erase some stuff here. Oh no, not really. I'm going to just talk about the time complexity here for a moment. Time complexity here is O of n squared, because we're going to have a for plus y loop. And it's a nested for loop. Now you can say, well, we have used a sorted function. Shouldn't actually be n squared plus n log n? And you'll be technically correct. If I can change my color without forgetting for the millionth time, thank you. This is fairly costly. But given that in the world of time complexity assumptions, we always care about which of the, when it comes to like adding complexities between like k plus b or n squared plus n log n squared would be greater than n log n in time complexity. So therefore, we would return that being the n squared. I hope that was helpful. I'm gonna go jump right down to the code and start code this up to solution. The coding is not too bad. I've shared most of the pseudocode on the far right as best that I could, and I hope that we can. Oh, sorry, dropped my pen. Yeah, I hope that the solution on the code will make a decent amount of sense. And yeah, let's again jump right into the code. All right, let's go ahead and try to code this solution up. So first, we would like to sort the input array. So nums.sort, and second, we would like to declare our variable that's going to hold the closest, initially starting at positive infinity. So closest is called flow. I think this is how you. Yep, there we go. And then call up our first for loop for I in range. Nums. Declaring our 2-pointer, so left and right are equal to I plus 1, and then length of nums minus 1, while left is smaller than the right pointer. We're going to calculate our current sum, which is nums of I plus nums of L plus nums of right. And now if the absolute target minus current sum smaller than the absolute target, there we go, make sure I spelled how I spell target. It's pretty late at night. Target minus the closest. And if that's the case, then the closest will equal to the current sum. If current sum is equal to the target, we would like to return current sum. Else if current sum is greater than the target, we would like to decrement our right pointer. Else we have reached a point where the current sum is smaller than the target. In that case, we would like to increment our left pointer in the hope of finding something larger than what we had to increase our current sum. So, and at the end, we would like to, in case we don't match and get the exact perfect value, we would like to return the closest value that we're able to get. So, yeah, most likely first you gotta sort the array, declare your closest variable as an infinite positive. You can put like 1,000,000, you can put 1,000, it doesn't matter. I like to put infinity just to be on the safe side. Maybe I'll put 1,000 just in case one of those weird edge cases, they have like 1,000,000, some guy made a test case, bless his heart. And starting off, you got that for loop that starts at, in this case, if you look at the example, it will start here, and you got a left pointer that starts right in front of the right I pointer, and you have the right pointer starting at the very end of the array. And we're going to compute and check, hey, but actually in this case, technically the ordering here is different than what we have right here because we haven't sorted. That being said, we're going to always get the current sum as long as our left pointers and right pointers haven't met, and checking what is the absolute difference between the target and the current sum versus the target and what we logged as the closest value. We want to get the smallest value, and that can only happen if the current sum difference is smaller than what we have already. And if it is that case, then we would update our closest value. And then we go through, I'll just add white space here, and say, hey, if the current sum is equal to the target, just return the current sum. Else if the current sum is greater than the target, and then we would decrement the right pointer, else the left pointer is going to be incremented by +1. Now in case we don't get to a point where we have found the exact perfect answer, but we have something pretty close to the current sum. This is where this return variable is doing. So hope that was pretty helpful. I'm going to run this code, make sure I didn't miss anything. So we pass our local. So let's go ahead and try to submit it. And bam. And again, time complexity is O of n squared, but if you guys don't believe me, here it is. And the memory is O of n as well. Oh, no, it is O of 1. Because, oh, yeah, we are only tracking value, a single value. We're not creating a whole list of arrays or using a data structure. So that is correct. It would be O of 1. Sorry about that. Hopefully this was helpful. It was pretty fun taking on this problem. And I hope to see you soon. Have a good one.